Latitudes. Has anybody ever heard of the horse latitudes? I mentioned them yesterday, I mentioned the horse latitudes, but didn't really explain what the horse latitudes were because I was kind of trying to focus on the big stuff. So these are the horse latitudes. I'm zooming in. Actually, when I click on this picture, it'll take us to this picture. This is from the NOAA website, National Oceanic and Atmospheric Administration, something like that. And they say the horse latitudes are roughly 30 degrees north of the equator and roughly 30 degrees south of the equator. So let me go to that page. Also, there are two questions. What are the horse latitudes? How do they get their name? So here's that same picture again. Now when they say roughly 30 degrees on the maps that we've been doing, let's see, get my picture up here. This map, the horse latitudes are where you see the deserts, and I've been telling you that they're centered at about 25 degrees. So these are the same things. The horse latitudes are the major deserts, where the major deserts are, and they're really at about 25 degrees. Although you can see that the deserts vary a little bit. I would say these lines are right at 25-ish. So let me zoom in a bit. Oh, I tried to zoom in, but it looked like I zoomed out. If you look all the way across, following this red line, desert there. This isn't desert. We'll talk about that at some point. So this is the Atacama Desert. This is the Kalahari Desert. This is the Great Australian Outback. This is the Sahara. This is the Sonoran Desert. And I think that's the Gobi Desert up there. Although there's some other weird stuff going on right here with the Himalayas. So horse latitudes. There's no way I think you would guess why the horse latitudes are called the horse latitudes. So I'm just going to read what NOAA says. Let me go up a little bit. See if I can find some information about NOAA for you. National Oceanic Service. So it's the National Oceanic and Atmospheric Administration. That's what NOAA stands for. Got a nice, I don't know if that's an albatross or a seagull. Horse latitudes are subtropical regions known for calm winds and little precipitation. So it still doesn't relate to horses. It says they're located about 30 degrees north and south of the equator. Let me read a little bit more here. The horse latitudes are located 30 degrees, about 25 degrees really, north and south of the equator. It's common in this region of the subtropics for winds to diverge and either flow toward the poles or toward the equator. So what they're talking about there, let me jump back to this picture that I have. Notice right here where my mouse is moving along, it says subtropical high. I could have sworn this said horse latitudes at some point. Oh yeah, there it is. Yeah, there's the horse latitudes. So you can see that the wind flows to the north and goes right through Vermont right here, but it also flows to the south because this is high pressure, and high pressure causes wind moving away from it. And if you look at it from a side view, what's really happening is this air is sinking in the horse latitudes from high in the atmosphere, and then when it gets to the Earth's surface, it splits, and some goes north and some goes south. So these diverging winds are the result of high pressure, which is characterized by calm winds, sunny skies, little or no precipitation, which is why the major deserts are there. So now we get to the horse latitude part. According to the legend, the term comes from ships sailing to the New World that would often become stalled for days or even weeks when they encountered areas of high pressure and calm winds. So you get into the horse latitudes right here, and there isn't any wind. Here there's wind, there's wind, but you can see right in between them, this is just dry sinking air. And what sailors named the horse latitudes, they needed wind in order to go. So they would just get stuck there, but we still haven't seen the connection to horses. Can anybody see a connection between getting stuck here where there's no wind and not being able to sail and naming it after horses? All right, let's keep reading now. Many of these ships carried horses to the Americas as part of their cargo. Unable to sail and resupply due to lack of wind, crews often ran out of drinking water. To conserve scarce water, sailors on these ships would sometimes throw the horses they were transporting overboard. Thus the phrase horse latitudes was born. So that doesn't really explain things to me. So the horses are drinking water. Why not just stop giving the horses water? And if they survive, great. If they die of thirst, then throw them overboard. Maybe that's what they did. Some people have suggested that what's happening here is the sailors are they're stuck and they need to row. I don't know if you can even row those big ships. Or they're thinking that whatever wind they have will push the ship faster if it's lighter, so they throw the horses overboard. Some people have suggested that they get here and they're dying of thirst, so they drink the horse's blood. Would that help your thirst? It's too concentrated. That would be like drinking salt water, I would think. So that'd probably just make them thirstier unless they could filter it. So anyway, I've read accounts that these areas there were a bunch of horse carcasses floating around in this region because they were thrown overboard to somehow allow the sailors to escape this place where they were running out of drinking water. Either to make the water last longer or make the ship move faster. All right, so that's the horse latitudes. That's dry, sinking air. And then the next question is about this other place. What is or are, I can't really tell if it's singular or plural, the doldrums? Where did the name come from? Has anybody ever heard the word doldrums? Anybody at home, have you ever heard the word doldrums? Anybody? Okay, so
I haven't.
You haven't? At least I got a confirmation that you haven't. So when I was a kid, I think this is an old expression, but people used to talk about being down in the doldrums. It meant depressed. And there's a long explanation. If you click this first link, the second link, where did it come from? It's actually kind of a convoluted story. But let me just jump to what the doldrums are, and then I'll tell you how the name is related to a saying. So the doldrums. Doldrums is a popular nautical term that refers to the belt around the Earth near the equator, where sailing ships sometimes get stuck on windless waters. So this is a lot like the horse latitudes. I go down here. Here are the horse latitudes, and here are the doldrums. The difference between the horse latitudes and the doldrums is at the horse latitudes, the air is sinking and there's high pressure and it's really dry. At the doldrums, the air is rising and there's low pressure and it's really wet. But the thing they both have in common is they don't have any wind. So ships can sail in here where the trade winds are, and they can sail up here where the westerlies are, and they can sail in these trade winds. But if they get into this area where it says equatorial low, doldrums, they get stuck again. So the good news is if you're stuck in a cloudy, rainy place, you're not going to die of water or of thirst. So they didn't have to throw the horses overboard, but they just got really bored. So the expression down in the doldrums means depressed, sort of sad, dumpy. And I'll click on this other link. This is some website, phrases.org.uk, that explains the phrase down in the doldrums. And it says down in the doldrums means low spirits, feeling dull and drowsy. And when they talk about where did the phrase come from, they say that the doldrums is actually named after the word, doldrum, which was a word for dullard, a dull, sluggish fellow. And this probably came from DOL, which meant dull, and which was taken from tantrum, which was a fit of, is this sloth or is it sloth? I think it's sloth, or dullness, or one who indulged in such. So, Doldrum was sort of, the word had to do with low spirits in the beginning. And then some writer, I think it was Lord Byron, who named the doldrums this because it already meant dull. So the answer to, like, how did the doldrums get its name? Let me go back to this. It's because Lord Byron recognized this as a depressing place, and doldrums was a word that connotes depression and dullness and boredom and all that. So that's why it's called that, and that's where the expression comes from. You'll probably never hear it again unless you're talking to your great-grandmother or somebody. This is the only people who use that. All right, this says discuss the homework. I think, though, if I refresh, this is going to say something different. What's the goal here? Look at satellite maps. So we've been drawing this, and we're going to continue to draw this. We're going to add some stuff to this, and then we're going to do some real maps of Australia and South America, North America, Africa, and you're going to have some quizzes over fake places that I've made up, and you're going to have to do a project where you make up your own fake continent, and then you've got to tell me what all of the climate features are. But the point of this is for you to be able to either look at something like what I'm showing you now and explain to me why why it's green and why it's brown in certain places, or if I gave you this and I didn't have any of these colors, you would be able to look at the latitude here and you'd be able to figure out, like, this needs to be desert, this needs to be rainforest, this needs to be rainforest. All the variation that you're seeing, mostly in green and brown, you're going to be able to understand, explain what's causing all of it, and tell me. So, South America is kind of a good one to look at. If you look at this coastline right here, it's all grayish, brownish. So is it wet or is it dry? What do you think? Dry. This is dry. This is a desert. And right here, this is the rainforest. If you look at this coast over to the right, same latitude and everything, it's green, so it's pretty wet. If I travel down South America, the desert gets even bigger right here. And then it starts to shrink, and then an odd thing happens. You can see on the east side of this desert, this is the Atacama Desert. By the way, this desert, there are places in here that get about 1 inch of rainfall every 1,000 years. So this is the driest desert in the world. And so this right over here, though, is a little bit wet. There it's super dry. And if I go a little farther south, that switches, and now the west side is wet, and the east side is dry. So that'll make perfect sense when we get to the Australia map, or at least it should, because it's all based on physical science and stuff we can explain. If you look at Africa, Southern Africa, see this funny pattern. The west coast right here is really dry. The east coast is wet. There's some wet down there. Moving over to, and even Madagascar. We're not going to deal with Madagascar, but it's really clearly got a wet side and a drier side. Same with Australia when we get to that. Plus it's got a few extra odd tidbits thrown in there. The east coast, you can see, is nice and green over here. Then central Australia, that's where the outback is. That's really dry, but right up here next to the water, right down to the water, is super dry. But then there's this tip here that's wet. It's wet there. Got some vegetation around here. It's mostly the center of Australia and right over here. We're not going to do a map of Asia because Asia is really complicated. It has a thing called the monsoons that we'll talk about later that make India really wet sometimes and really dry sometimes, and it just doesn't work out right. If we try to map this using the concepts we're using to map everything else, it's I'm going to spend so much time saying, well, this is an exception and here's another exception, so we're just leaving Asia out. We'll talk about it a little bit. At any rate, I want you to know why there's this pattern. There's a very predictable pattern of dry and wet. all over the world. Where we live, the United States, you can see right along, well, here it's dry, there it's dry, the Baja Peninsula is dry. As you move up the coast of western North America, California is fairly dry, but the Sierra Nevada mountains are wet. And then get into Washington, it gets really wet. The East Coast, no matter which latitude we're talking about, it's not a really dry place. And Florida is kind of an exception. If you look at Florida, if you go straight across, this is where all the major deserts of the world should be, but Florida is not a desert. Okay, so the point of doing these maps is to understand why all these patterns exist and to be able to explain them all. So I'm going to go back to here, and what we're going to do is create and draw. It says create and draw another map, but we're actually going to finish the map that we started on yesterday. And then after that, we're going to start a new map. So people at home, people here, try to find the map you're working on yesterday in class. If you weren't in class yesterday, I don't know, just try to jump in and follow along in whatever manner that you can. And you're going to need, just like yesterday, you're going to need a red and a blue and a green and a brown, something to do warm water, cold water, and wet and dry. On this map, from here on out, all I'm going to need is some green and brown. But we'll do another one. We're going to need other stuff. So everybody spend some time getting your stuff. I'm going to go walk across the room and get myself some colored pencils. And I'll be right back to finish this up. We've got to add 3 things to this map. Got them all? What's that? Yeah. So hopefully you have 2 of these now. You have this one and you have the one that I wanted you to do for practice. Your homework was to redo this and try to basically get another map up to this point. Just go from memory, do as much as you can, then look at this and until you've got 2 maps that are like this. So your homework for tonight is to do to your other map, like the second copy that you've made, whatever we're about to do to this one. We're going to add 3 things to this. We're going to add, so we've got pressure belts, winds, ocean currents, major rainforest and desert. We're about to add rain shadow effect, coastal wet, and humid climates. So I'm just going to write the next one. This next thing we're going to do is the rain shadow. And I'm keeping my little list of notes on how do I do it. It doesn't really explain the rain shadow so much, but it tells me how to draw it on the map. That's what this list is doing. Rain shadow, by the way, if you're somebody who really cares, it's not one word. I tend to write it as one word and I say it like it's one word. Having trouble, Tommy? Keep looking, I think you can. If you don't have colors that are exactly right, just find something that'll do for warm, cold, wet, and dry. All right, so the rain shadow effect, I'm going to draw a picture on here. You don't need to draw a picture, but I'm going to do this just to illustrate what's going on. I don't know if you remember this from the warm-up yesterday, but it's super important to know what kind of motion of air gives you wet and what kind gives you dry. So if you have some wind, here's the wind, and you have a mountain range, this wind has got to go over the mountain. And in order to go over the mountain, it has to rise up on one side, and it has to sink on the other side. And hopefully, just based on that, you could tell me which side of this is wet and which is dry, because on one side it's sinking and one side is rising, and one of those means we're going to get clouds and precipitation. If you don't remember that, just right off the bat, then a hint is as air rises, it goes up and encounters lower pressure. This is the long way to do it, but this is the best way to understand it. Is as air goes up, there's less pressure. So if you imagine some air rising, it's going to expand as it goes up because there's less pressure squeezing it. And as air expands, when a gas expands, it cools off. So this rising air is going to get cooler. And then when it goes back down, it's going to encounter more pressure, so it's going to get compressed again, and that's going to heat it back up. So when it rises, it cools, and when it sinks, it heats up. Now, which one causes condensation? Which one causes gas to turn to a liquid? Is that the cooling, or is that heating? What's that? Heating. So if I have a, let's see, if I have some water and I heat it, is that going to make it turn to a liquid or to a gas if I heat it and heat it and heat it? What's that? It'll turn it to a gas. So what's happening here is on the way down, if I have some liquid droplets, let's say I have a cloud right here. As the cloud goes down, that's going to heat up and it's going to evaporate. So as the air rises and it cools off, just like if I blow my breath against the cold window over there, condensation is going to form. So this is the side that's going to be wet. And then over here, this is the side that's going to be dry. So there's a short way to remember that. Most people say the windward side is wet and the leeward side is dry. So the windward side is the side that the wind comes from. So the wind hits this side of the mountain, that forces the air to rise up, expand, cool off, and water condenses as clouds. And then when it goes down this side on the leeward side, this is the windward, and this is the leeward. As it comes down, it heats up, and that causes water to evaporate. And what about the top? So if you go skiing, if you're a skier, as you go up the mountain, do you find more snow or less snow? More snow. And there's the most snow at the top. Now if you go down the other side, there's going to be less and less and less. So I'm going to add one other thing. The top is also wet. All right, so that's all we need for the rain shadow. This is a side view. It's pretty easy to understand. This map view is maybe a little trickier, but that's okay. So we need two things for a rain shadow. We need wind and we need mountains. And right up here, we've got both. The black arrows, those are my winds. So my wind is coming from the left side. I'll use my pencil as a pointer. It's going to hit the mountains like that. Which side is the windward side? The left or the right? The windward side is the side that the air hits first. So as the wind moves across from left to right, it's going to hit this side first. It's going to rise on this side. So this side's going to be wet. So all through here, this is wet. Now, when I draw this, notice that I have desert right here. I don't want to make my wet place touch my desert. But I'm going to make the top of the mountains wet, and I'm going to make the windward side of the mountains wet. My color isn't great on this camera. I don't know if you can see my color. It's kind of washed out. Sorry about that. And then back behind here, on this side is dry. Now the dry part, you've got a dry area next to a desert. The dry is probably going to be a little bit bigger on the desert side, so it'll connect up to that. And it'll get smaller as you go away from the desert. So there. So air starts to go up the mountains. That makes clouds. Top of the mountains, they're wet. Then it comes down the other side, and that makes it dry. Now I don't want to have brown touching green. I don't know. I think that's a little weird, although you could. I'm leaving a little space in there with mine. So that's it. It's that easy. Now, right in here, this is the, is this the horse latitudes or is this the doldrums? Anybody from home know? Can you identify this place that I'm drawing with my pencil? Horse latitudes or doldrums? This is the horse latitudes. This is where they were, the people out in their ships don't have any wind and they're drying out, they're dying of thirst, they throw the horses overboard. So we don't have wind here, so that means there's no rain shadow effect because there's no wind blowing over the mountains, there's just sinking air. Do we have wind here? Yes, all right, so right here, which side's wet, which side's dry? Look at the wind. The wind is coming like this, it's going from right to left, it's coming, these are the northeast trade winds. Which side is the windward side? The right side or the left side? Tyler, which side's the windward side? Right side or left? What's that? The right. So the wind is going to hit the right side. So that means this right side, this is the wet side now, over here. And the mountains themselves, the tops of them are going to be wet. And it's between a desert and a rainforest. I'm going to make the wet side a little bit bigger by the rainforest and smaller by the desert. And then that means this side over here, this is the dry side. And that dry part, I'm going to make it small by the rainforest, but big by the desert, which hopefully makes sense. As you go from here to here, things get wetter. As you go from here to here, things get drier. Who can tell me, can anybody tell me how many more rain shadow effects we're going to have in this picture? If I draw all the other places where we have a rain shadow, so far I've drawn 2. How many more are there? So we just need places where there's wind and mountains. And right here, there are mountains, but there's no wind. This is just this is the doldrums where the air is rising. Here, we've got mountains and wind, so it's going to happen there. Here, we have mountains, but we don't have wind. We just have sinking air. Here, we've got mountains and we have wind. So we're going to have 2 more places. And all you have to do is make the windward side wet and the leeward side dry. So here the wind comes from the right. That means the right side's the windward side. That's where the air is going to rise. So make that wet. And then back on the other side, this is where it's going to sink. Make that dry, and notice that I'm making my dry side bigger close to the desert and my wet side bigger closer to the rainforest. If you don't do that, it's not a huge deal. I just would definitely want this side to be wet and that side to be dry, and the top should be wet. And then down here, the wind comes from the left, so the mountains are wet, the left side is wet, and then the right side, where the air sinks, is dry. So the thing that every place on this map has in common, if it's got green, all those places are rising air. If there's brown, all those places are sinking air. With the rain shadow, the rising and the sinking are caused by the air going over the mountains. It's rising and then sinking. Rising on this side, sinking on that side. Rising here, sinking there. The other places like the doldrums and the horse latitudes, this is just the atmosphere circulation. This is the air coming down, or sorry, rising up into the atmosphere. This is it coming down out of the atmosphere. All right. Any questions? So next thing, this one, number 7, there are a couple of different ways to think about this one, and maybe different names for this. I call it coastal wet. So there are certain places along the coastline that are going to be wetter than others. And we saw that when I was showing you satellite pictures. Here, for example, if you look at this coast of South America, it's wet. This coast is dry. Generally in North America, not a great pattern, but the East Coast is wet, West Coast is dry. You can definitely see it in, well, you can see it in Southern Africa. This is dry, this is wet. You can see it in Madagascar. You can see it in Australia, dry on this coast, wet on that coast. So I don't want to, I'll write my notes in just a second after I show you this, but I want you to see if you can figure it out. There may be a couple of ways to talk about it, but you have to look at the wind and the coastline. So this coast right over here and this coast right over there. We got the East Coast, we have the West Coast. Because of the wind blowing to the west, one of these two coastlines is going to be wetter than the other. They're going to have more rain either right here where I'm making my dot or here where I'm making my square. One of those places is going to be wetter. Can you guess which one? So there are two ways to think about it. One way is, what kind of air, let me put my picture back. What kind of air do you think would have more rain in it? Air that's coming from land or air that's coming from ocean? Ocean. So if you look where my little dot is and look at the direction of the wind, is that wind coming, when it gets to the dot, is it coming from the ocean or is it coming from the land? It's going like this. It's coming from the ocean. Now if you look at where the square is, this wind is coming from the land. So this is going to be wetter. This will be a coastal wet region, and this will be not. The other way to think about this is it's the rain shadow effect again. If you have some land and you have ocean, in order to come onto the land, what does the wind need to do? Does it need to sink down or rise up? It's got to rise up a little bit. Not a lot, but a little bit. So rising equals wet. So this is, I guess, we could probably just use the same terminology as the rain shadow. I've never done this before. Maybe this won't work for you. I'm going to say the windward coast is wet, and the leeward coast, actually, I'm not even going to write anything about that. I'm not going to say it's not. It's just, I don't want to say it's dry. It's not going to be particularly dry necessarily, but the windward coast is wet. So there we go. And if I were to draw a full ocean, like this, where you could see windward and leeward, I don't know if that really describes it. This is the one, this is the wet one, and this is the one that's not wet. So I don't really like that. I'm going to say wind wet equals wind comes from ocean onto land. Let me make this a little bit neater. So you just have to go around the edge of your continent to all the coastlines and look for places where the wind is coming from the water onto the land. And there are 1, 2, 3, 4 of those on this map. I'm going to go ahead and do this one because we talked about it. So this area right here, this is wet, and I'm making the the wet part a little bit bigger where it touches the rainforest. And I'm making it smaller down here for two reasons. One, there isn't any wind here. And two, this is a dry area. So there we have it. All right. I want somebody from home to butt in. I'm just going to move my pencil around the coast. I want somebody to butt in and say, stop, when I get to the next place that's wet because of wind coming from the ocean. So I could be moving my pencil around for a long time.
Stop.
Ah, good. I was worried that I would be doing this forever. Yeah, so this place right here. And I don't want to have my wet quite touching the desert because that doesn't make any sense just to go suddenly from dry to wet. But this corner right here, that's where, if you're standing on this coastline, the wind is you're gonna feel a breeze in your face. If you're over here and you're looking out to sea, the breeze is gonna be coming from the land behind you, so that's not wet. All right, there are two more. I'm gonna keep moving my pencil. Tell me when to stop. Tell me when I get to the next place. Actually, I'm just moving my paper. Stop. Okay, somebody in here told me to stop. This is the next one. Right there. There's the wind. It's coming from our left, hitting the coastline right there. So that's going to be wet. And there's one more. There's one more place. If you know where it is, you can go ahead and make it green. But otherwise, I'm going to keep traveling around. Tell me when I get to a place where the wind is coming from the ocean onto the land.
Stop.
Yep, right here. Now, I don't know if you've picked up on this, but do you see the symmetry of this map? If I fold this map, it won't be like this with every continent, but if I fold it right on the equator, everything more or less matches up on the left side and the right side. Whatever I have over here is the mirror image of whatever I have over there. I'm going to mention it. Actually, there's one more thing, and then there's the last thing I'll point out, just because some of you have probably been wondering about it. So, humid climates. And I add this one because we're kind of in this. The East Coast in the summer gets really humid. And we're sort of on the East Coast. We're not too far from the East Coast. Humid climates. But California, Washington, Oregon, they're not humid. They might get a lot of rain in Washington State, but it's not a humid place. So humid climates are, well, before I write it, let's do it. So remember what I was saying about somebody taking a hot shower versus a cold shower? This whole East Coast has warm water, and most East Coasts do. So that's like a bathroom. The whole East Coast is like a bathroom where somebody just took a hot shower. And the whole West Coast is like a bathroom where somebody took a cold shower. So this whole coastline is going to be steamier and more humid than this one. But there are a few places on this East Coast that other things are going on. Like right in here, where this dry sinking area is in the horse latitudes, it's not desert, but I wouldn't say it's going to be super humid here just because of all the dry sinking air. And right here, this is already a really rainy place. So there's already a name for this. We're already calling this a coastal wet climate. And this is major rainforest. So we're not going to call that humid because it's got something else going on. But there are a few places like right here in this area. I kind of wish I had a different color. So I think what I'm going to do, since I don't really have a different color, is I'm going to use some sort of a pattern with my green. But next to this warm water, right in here, this area, that's just going to be, I would call that a humid climate. And I suppose you could also put some of that right in here, because it's close to this warm water too. And then right over here, and also down here. It's basically the side of the continent, so the east side of the continent, that's not anything else already, because it's near this warm water. It's going to make it humid. So how would I write that? The humid climates are, I'm going to call them I want to call them unoccupied areas on the east, on the warm water side of the continent. Maybe I'll just say open spaces on the climate map on the east, or sorry, on the warm water side of the continent. Okay, I'm pretty happy with that. Now it's usually, the warm water is usually going to be on the east side. If you go swimming on the east coast and the west coast of North America, it's the east coast that's going to be warm and the west coast is going to be cold. Has anybody in this class ever been out to California or Oregon swimming? Ms. McGurk? Anybody else been out there swimming in California? I want to show you where I went swimming one time. It was cold, right? Yeah. So I went to Camarillo, or Camarillo, I think it's called. That's where my cousin lives. Somewhere, okay, I'm in the wrong hemisphere. Somewhere around Los Angeles. I'm not really good with my California geography, but I think it was basically somewhere right in here. And if you go across the United States to an equal latitude, I just go straight across, that puts me right around South Carolina. If you go swimming in South Carolina in the summer, it's nice and warm, not cold at all. But if you go straight across at the same latitude and go swimming off the coast of California, you may need a wetsuit. A lot of people would. I used a wetsuit when I was out there. And I also got beaten by the waves. The waves were much bigger than here on the East Coast. And then if you move farther north, the same thing holds. If you go swimming in Maine, and then you go straight across and you try to swim at an equal latitude off the coast of Washington, it's much colder in Washington. Now, Maine might be kind of cold if you've been swimming at the beach there, but it's nothing compared to off the coast of Washington. And it's because of the ocean currents. The ocean currents on the East Coast come from up from the equator like this, and the ocean currents on the West Coast come down from Alaska this way. All right, 8:45. I feel like I've been kind of pushing people pretty hard and talking a lot, so maybe we'll just wrap this up for today. So your assignment, if you didn't do yesterday's assignment, hopefully you can use this extra time to catch up. I want you to try to recreate this on another sheet of paper. Basically draw lines of latitude like this, evenly spaced. Make a blocky shaped continent that goes almost to 50 degrees north and almost to 50 degrees south. Put a chain of mountains right down the middle, and then go through all these steps of adding in the pressure belts and the winds and the ocean currents, the major rainforest and desert, rain shadow, coastal wet, and humid climates. Now, if you did the homework last night, all you have to do is add these 3 that we just added on today. Tomorrow, I'm going to have you make a video, just because that's a good time to practice making a video. And then on Thursday, everybody who is here, you're going to get this. We're going to do some of the, we'll do some of the real continents. We'll do Australia. We'll do,
I have a question.
yeah, Megan.
Do you know what number 5 was?
Number 5? Oh, there is no number 5. I just went on my sheet from number 4 right to number 6. So I guess I should renumber that. So yesterday I made a scan of this and I put it in Google Classroom. So I'll do that right now. I'll scan both sides of this paper and I'll put a PDF of that in Google Classroom if anybody wants to look at it. So you can follow these steps. But try as much as possible just to look at this part first and say, okay, where do my pressure belts go? Where do the H's and the L's go on the map? And then try to put them on. And if you need to look at this, low at the equator, H and L alternate at 0, 20, then you can look at that. And if that fails, then you can go back and look at the map you've already drawn to see where you put the H's and L's. And then go on to the winds. And don't look at the hints, but try to draw the winds. And if you need to look at the hints, then look at them. And if that fails, then you can go back and look at the map. I'll scan my map too, so you can have my example to look at. So, anybody have any questions? All right. See you all tomorrow. Happy Blue Friday. All right. Do my scanning.